I know where there's some, right here in the hall, clerk.
No, Molly, not in there. I have enough.
Welcome back. Here we are continuing on this Continental M500. Just removed the tuning condenser, and it's mounted by, used to be 3, and now it's 2 very sad grommets. And as I suspected, the condenser itself is supposed to be floating above this even. So these 3 are for mounting to keep vibration down, I suspect, since this is a portable radio. These are the actual insulating points for the condenser itself, so it doesn't get grounded. In fact, I know that's true. There's a solder lug right here that solders to the chassis right over there. So I've got to take these 3 screws out and replace those grommets. Fortunately, today in the mail came a box of grommets, and some of them are very tiny, which is just what I need, is very tiny grommets. These little guys are quite small. So they go, this is the smallest, that's the biggest right there. And there's some other sizes as well. But I think these are the ones I'm going to end up using mostly. I might use these as well. Not sure yet. So now what I have to do is, and I'm going to do it off camera, is remove these 3 screws, insert grommets best I can into this plate right here, and remount that, and then put new grommets in here and remount the whole thing back to the chassis. At that point, the other update is a new on-off switch / potentiometer volume pot. It just barely clears in this dimension. It just barely goes in the case, but it does. I had to bend these connection tabs over before I soldered to them, but I think it'll be okay. So my goal of this video is to get this all put back together and try it one more time, and then do an alignment on it. Yeah, that's the goal. So we'll see if we get through that in something less than 4 hours. Okay, where are we? The tuning cap is remounted with rubber instead of just screws. A couple of new grommets in the loopstick antenna. The new switch is in, of course. I have another battery taped in here because the battery holder doesn't work unless it's in the case, and then we've got our B+ battery hooked up. So let's see if it comes on and what happens if it does. It's so weird to turn on a radio and not see the filaments glow. Oh, that's a good sign.
We saw with the shampoo, we saw with the greens, it's going to expose you. And that's what the USDA does. That's why it's the hardest setup in all the major championships, I feel like. And Mickelson, to me, especially with his arthritis, too. Coach first in the NBA, I ultimately think it's the players who decide.
All right. picking up a few things. We're we're in the basement here of this house, so not much to be heard. Yeah. But it's working. All right. So what I want to do now is check the alignment of this radio. And mostly because I monkeyed with the antenna, so the antenna trimmer is probably off by a bit. And I have no idea. It looks like, if you look right here, these are the two, this only has 2 IF transformers. But they've been painted down, so it looks like they haven't been changed, but I'll do it just for giggles. First thing to know is what the IF frequency is for this radio. And the fact of the matter is, we don't have a clue. It doesn't say anywhere in here what the IF frequency is. As you can see, there's one IF can, there's the other one. They're labeled A and B. I presume this one is the A. I presume this one is the B. I can figure that out by seeing if there's a lead from the B one that goes into the first grid of the 1U5. So I'll do that and see if this is A or B, and then we'll start the process. All right, I've determined that first IF can, which is this guy, is labeled A, and it is indeed the first IF can in the circuit. So this is the second one. I'll put the tube back. I was looking at the schematic of this radio, and the 1R5, which is this guy right here, does a lot of stuff. It's just very busy. But it is a heptode, Heptode. And I remember when we were in school, the bad joke of the day is, what's a heptode? It's a groovy frog. So there's a bad joke for you from a lot of years ago. Okay, what we want to do to align this is we want to inject RF, in essence. We want to inject, well, first we want to find out what the IF frequency is. And it should be, this is 1954, it should be around 455, even though it's made in Japan. They were following American standards by this time. In further looking, by the way, this is almost an identical copy, blow for blow, of the RCA B411, which came out in 1950. This is from 1954. So this is pretty much a direct copy of the RCA radio, I believe. So what we're going to do is we're going to disable the local oscillator by grounding one side of the local oscillator's tuning coil. So the first thing we have to do is find out which one that is. And there's a way to do that that's kind of interesting. If you turn the radio on, you find yourself a station.
Choose your distance. Half marathon, 10K.
There's one. If you touch the fins of the tuning condenser, there are two condensers in here, remember. One is for the local oscillator, the local oscillator that helps generate the IF frequency. The other is for the RF signal itself. So if you touch the RF signal one, you won't see much difference. In fact, enhances the signal a little bit. If you touch the other one, it detunes the local oscillator, and so it cripples the radio in essence. It stops the local oscillator from oscillating at the frequency it should, and therefore disables the IF frequency throughout the radio. So we know now that this is the tuner, the larger of the two, and the local oscillator is the smaller of the two. So now we have that bit of information. We can get ready. What I have here is my trusty signal generator, my leader. I have my trusty Simpson voltmeter, VON, and I'm going to set this all up and get the extra junk out of the way so that we're ready to, what we'll do is disable the local oscillator, then we'll inject an RF signal, and we'll sweep around from like 465 down to 150. Intermediate frequencies are in that range typically for broadcast band radios. So if we inject a signal in here in the appropriate place and sweep from 465, which on this is right around there, down to 150, we'll hear it. We'll hear the intermediate frequency because this generates a tone, and if we're injecting the correct intermediate frequency, and it's not all broken, and we know it isn't because the radio works, but we'll inject the intermediate frequency, we'll hear the tone of the frequency. And that's what we're going to try right now. Okay, here's the setup we've got. I have grounded the oscillator condenser to the chassis, to the frames, with this grain cable. I've attached the signal generator through a 0.22 microfarad capacitor to the control grid, the first grid of the multi-purpose heptode here. Okay, I've got the signal generator hooked up through the cap, connected to the ground lead of the signal generator is connected directly to the chassis. Going through this cap right here to the first grid of the mixer tube. So we should, this is on, we're in channel, range B, which includes 455 is right there at that mark. So we should hear a tone here pretty soon. Oh, there it is. Well, it's peaking really a lot lower than I would have guessed. Right here in this dial is 455, and this is pretty accurate. It's not digital, but who cares? So it's that little hash mark right there on that scale, and this says the IF for this radio right now is tuned down here around 4, what is that, 10, 20, 30, 435, 440. 440, that's a note. So it's possible that it came out of the factory this way. Seems kind of odd. By 1954, things have been pretty standardized around the world. Yeah, so that's peaking right at 440. Interesting. Well, I think we'll adjust it to 455, which is quite a ways off. So again, to get to this point, if you don't know what the IF frequency of the radio is, ground, disable the local oscillator, inject a signal very near the front end, in this case because it's a heptode, or a groovy frog, if you will. You inject the signal up there through a capacitor, and then sweep back and forth. There are harmonics. We'll see if we can pick up a harmonic. Kind of doubt it, but it's possible. There would be a harmonic way down here somewhere. Nope. All we're getting is the fundamental of the IF frequency. Okay, so we'll move on from here. We'll do our next setup. Weep.